So let's pick up right where the other video left off. Factoring by grouping. What is factoring by grouping? Factoring by grouping is simply separating a polynomial into two groups. You factor something out of the first group, factor something out of the second group, then you take a step back and factor something in common out of the whole thing. But what I would like to do is zoom in on the word common, and let's add the word binomial. So I want to factor out a common binomial from both groups. And it'll make sense right now once we go through an example. So the steps on factoring by grouping are right here. 1, 2, 3. Step 1 is to separate it into two groups. All you do is rewrite it, but make some space between your first two terms and your second two terms. Step 2, factor something out of each group. See if you can pull something out of the first group. Pull something out of the second group. Then you go to step 3. What's step 3? Factor out the common binomial from both groups. Okay? And write down some exaggerated parentheses. Okay, that won't make sense until you actually see it. Check it out. So here's our factor problem. There's 4 terms. X to the third plus x squared plus x plus 1. And normally you would look at this thing and say, well, let me try to pull out an x. But you can't pull out an x because there's no x on the last one, right? So as of right now, we're stuck until we learn factoring by grouping. The first step on factoring by grouping is to create two groups. So notice, you just take the 4 terms and you rewrite it. First 2 terms there, leave some space. Second 2 terms right there. Now, instead of just walking through, I want us to actually write the work. That's why I left a little bit of space right here. So let's go. What's step 2? I already separated the first group and the second group. There's first group, there's second group. What does it say on step 2 over there to the left? Anybody, read it to me. Factor something out of each group. Okay, so let's focus in on the first group, and let's all put parentheses right below it. And what could I pull out of those 2 terms? What could I pull out of those 2 terms? An x. Not only one x, but an x squared, right? You could pull out a maximum of 2 x's. What would be left on the inside of the parentheses? X squared times what gets us x to the third? X and plus 1. Thank you very much. So we pulled out something from the first group. Let's go to the second group. Let's go over here to this guy. What could I pull out of this guy? Technically, right now, nothing, right? I mean, if you think about it, there are no x's in common in both. There are no numbers in common in both. But the instructions say pull something out of each group. It doesn't say if you can. It says pull something. You have to pull something out, right? So even if you can't pull something out, we're going to pull something out. And what's that going to be? A 1. Now, that is honestly ridiculous, pulling out a 1. Why is it ridiculous? Because 1 times what gets you x? X. And 1 times what gets you 1? 1. A positive 1, right? So pulling out a 1 doesn't do anything, right? But we're going to do it for the sake of factoring by grouping, okay? Obviously, I pulled out a 1. You still end up with the x. You still end up with the 1. Pulling out a 1 does not do anything. This is the only time you'd actually pull out a 1 when you're factoring by grouping. Now, why is that? Because the next step, if you read it right here on the side, it says, step 3, factor out the common binomial from both groups. So obviously, I did this work for you. I pulled out the x squared. There's an x plus 1. I pulled out the 1. There's an x plus 1. Pulled out the 1, the x plus 1. And it says pull out the common binomial. What binomial is in common in the first group and in the second group? The binomial x plus 1 is in common in both groups. Okay. So let's go to this area. Even though I already did the work for you, let's go to this area right here. And this is what I would like you to do. Let's go for some exaggerated parentheses. And let's pull out that common binomial of x plus 1. I want to put it right here. X plus 1. I'm pulling out the x plus 1. So right here there's an x plus 1. Right here there's an x plus 1. I'm going to pull out those x plus 1s and just write it once out here. And what would be left on the inside? That's right. So let's put that. This x squared, I'm just going to rewrite right here. And this plus 1 right here, I'm just going to rewrite right there. So why do I leave these exaggerated parentheses for you guys right now? When you do the first 4 or 5 of these that you're practicing, that you're learning, I recommend leaving this empty space so you could clearly see that the x plus 1s that used to be here are now gone. They're out here. Okay. If I went from here to the final answer, a lot of us would get confused. But I leave the exaggerated parentheses. I pull out the binomial that's in common. I even do that right here. I leave a blank spot and a blank spot so you can see it. And then I rewrite my answer in the appropriate size parentheses. Okay. So believe it or not, we have factored. If I were to take this x and distribute it, x times x squared, I'd get x to the third. X times 1, I'd get 1x. 1 times x squared is 1x squared. 1 times 1 is 1. And you'd rearrange it and you'd get to that original polynomial, 4 terms, that has the highest power of 3. Okay, so we are able to factor these. Just because you don't have a common factor, a GCF, doesn't mean that we're stuck. If you have 4 terms, try factoring by grouping. Okay? So, let's try factoring by grouping on number 1. Okay. What's the first step?
Separate
two groups. Okay, so let's just rewrite it. 3x, you got to write really small, either that or rewrite it in your notebook. 3x to the third. Now notice I'm leaving some space right here because I don't have to pull out that common binomial. So that's why I didn't write it over here on the edge. I left some space. So 3x to the third plus x squared space positive 15x plus 5. So all I did was rewrite my first 2 right there, space, rewrite my second 2. And now step 2. What's step 2? That's right, factor something out of each group. So what could I pull out of the first group?
X squared.
X squared. Okay, what would be left if I pull out an x squared? X squared times what will take me back to the 3x squared? 3 and an x, somebody said, right? And then how about this? X squared times what will give me an x squared? 1, right? So let's put a plus 1 right there. So we factored something out of the first group. Let's go to the second group. What could I factor out of that second group?
5.
Yep, pull out a 5. And now look at, normally when we pull out a 5, we just write 5. But right now, let's put a plus if it's positive. Let's put a minus if it's negative, okay? So let's pull out that positive 5. What would be left on the inside? 3x plus 1, perfect. And we need these binomials to be identical. Because that's the next step, is to pull out the common binomial in both groups. If you did not have a common binomial, you wouldn't be able to pull it out. Okay, so it's very important that we end up with the same exact identical binomial so we could pull it out. So this next step is to exaggerate some parentheses and pull out that common binomial of 3x plus 1. Now what would be left on the inside of those exaggerated parentheses? The x squared comes down and the plus 5. So of course you don't want to leave it like that. You want to rewrite it in the appropriate size parentheses. 3x plus 1 times x squared plus 5. Now let's say you're doubting yourself, you're second guessing yourself. You're like, man, maybe I got this wrong. Let's say it's a test and you want to get an A, right? And you have some time left over. What could you do?
Foil.
You could foil, yeah. You could distribute, right? Distribute the 3x, and distribute the 1, then combine the like terms or arrange it, and it should give you the above 4-term polynomial. Okay? So again, step 1, make some space, create 2 groups. Then factor something out of the first group, factor something out of the second group. And then take that common binomial and factor it out of both groups. What's left over, that comes down, there's your answer. Easy peasy, lemon squeezy. I know, it's not easy. It becomes easy. The more you practice, the easier it gets, all right? So how about you guys practice right now? I'll pause it before I explain. I want to see if you guys could do this. Go for it. Let's do this. Step 1, separate it into 2 groups. As you can see, I purposely left some space out here because I do need space to pull out that common binomial once I get to that step. So leave some space. You got your 2 terms, space between them. First group, second group. Step 2, factor something out of that first group. And of course, the maximum amount of x's that you could pull out of those 2 terms at the same time is 4, x to the 4th. So if you do pull out an x to the 4th, you would have an x and a minus 2 left over. How did I do that? I thought x to the 4th times what will get us x to the 5th? That would be an x. X to the 4th times what would give us a negative 2 x to the 4th? That would be a negative 2. Let's do the same for the second group. Parenthesis, what could you pull out? What could you pull out? A 2, bless you. All right, so we're going to pull out that positive 2. And what would we have left? 2 times what is 2x? That would be an x. 2 times what is negative 4? That would be a negative 2. So now we use the exaggerated parentheses and we take that common binomial of x minus 2 and we pull it out of the whole thing. So what's left over? The x plus x to the 4th is what comes down. That's what's left over. And also the plus 2 comes down. That's what's left over. So your correct factored form is x minus 2 times x to the fourth plus 2. And of course, if you wanted to double check, all you got to do is distribute, and you'll see that you really will end up with that original four-term polynomial with the power of 5. Okay, now, we have factored quadratic trinomials before when the a value is 1, right? This a value right here is 1. And that's beautiful because you're able to set up the parenthesis and the x, and all you got to do is think what times what is the c value that if you combine together is the b value. Now, listen up, guys. What if I told you that I've been skipping some steps, right? On number 3, what we should have done is multiply a times c. That should be our first step. Step 1 is to multiply a times c. But what's 1 times 32? 32. Okay, and then step 2 is to make a list of the multiples of 32, right? Which is what we were doing before. We just say, what times what is 32 that if I add together is negative 8. So we make the list of 32. But technically, we've been skipping this first step of multiplying a times c. Why would I skip that first step? Because if you have a 1 out here, that's going to be your answer, right, for that first step. So I've purposely been skipping that first step of a times c, right? But over here, I must multiply a times c. And then after that, I think of the multiples of that answer that combine to give you b. Tip, make a list. And then after that, use that pair of numbers to rewrite the b value as 2 terms, giving you a total of 4-term polynomial instead of 3 terms. And then step 4, factoring by grouping. So this is going to be nuts. If you're yawning, wake up. If you're asleep, wake up. If you see your partner's falling asleep, wake them up. No slapping, but you could give them a little shove. Check it out. Number 1. Put attention, please. What's step 1? To multiply a times c. Write really small, guys. Write really small. A times c. A is 6. C is negative 3. What's my answer there? Negative 18. And let's actually box this in. Negative 18. That's what I want for step 1. What's the next step? You think of the multiples of that answer of negative 18 that combine together to give you the b value, which is negative 7. So don't even think about that part yet. Just make a list, right? That's what the instructions say. Make a list. How could I get negative 18? Negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it. Which pair of numbers combines together to give us the b value? Negative 2 and 9. If you combine negative 2 and 9 together, that will give me 7, and that's what I want, but I want a negative 7, not a regular 7. So just change those signs. So let's make that a positive 2 and a negative 9, and that's the pair of numbers that we want for step 2. Okay, now this is where it gets weird. This is where it gets weird. Step 3. What does step 3 above say?
Use the pair of numbers to rewrite the value of b as 2 terms.
Use this pair of numbers to rewrite the b value as 2 terms, creating a 4-term polynomial instead of 3. Okay, so this is going to be really weird. Check this out. I'm going to rewrite 6x squared, but instead of this negative 7x, I'm going to rewrite it as a positive 2x minus 9x. Where did I get this positive 2 and this negative 9 from? The pair of numbers from step 2. And the negative 3 is still right here. So let me write down negative 3 right there. So why the heck would I want to change 3 terms into 4 terms? So you can factor by grouping, right? So let's now do step 4, which is factoring by grouping, okay? Which is what we just learned above. So let's take this guy and rewrite it up here and do step 1 on factoring by grouping, which would be to separate it into 2 groups. We have 6x squared, we have plus 2x, we have space minus 9x minus 3. And now factoring by grouping, after you separate them, what do? You factor something out of the first group, factor something out of the second group, and then hopefully be able to factor out that common binomial. So let's put parentheses here. What could I pull out? 2 and an x. And what would be left on the inside? 3x plus 1. Perfect. Okay, how about in the second group, what could I pull out? You can pull out a 3, right? However, notice this binomial is both positive, right? You want this also to be both positive so you could end up with a common binomial. But you got negative terms right here, and you want them to be positive. So you need to pull out a negative sign in addition to the 3. I hope that's clear to everybody. We're going to pull out a negative 3. That way we could get the same identical 3x plus 1 right in there. Now, if you're like, oh, I want to pull out a 3, you're going to see that these are going to be negative, and you'd have to pull out a negative after that. So it's easier to think, oh, these are both negative. I need them to be positive, so I'm going to pull out a negative with the 3 that I'm pulling out. Anyway, the next step is to take a step back, do some exaggerated parentheses, and put that common binomial on the outside, that common binomial of 3x plus 1. What's left over? 2x and a minus 3. Let's write it with the same size parentheses, right? 3x plus 1 times 2x minus 3. We have factored using factoring by grouping. Okay? So factoring by grouping is everywhere. It's even in these simple ones. Like, check this out. Let's go through the whole process, even though it's completely ridiculous, but watch this. Step 1, multiply a times c. What's a? Well, what's a? This is the answer. But what's a and what's c? So 1 times negative 12, that will give us negative 12. And then step 2, think of the multiples of that answer, like negative 1 times 12, negative 2 times 6, negative 3 times 4. And which of those pair numbers combines together to give us the middle value b, which is 1? That'd be the negative 3 and the 4. Negative 3 and the 4, right? Step 3 is to rewrite your trinomial as 4 terms, x squared, but instead of plus 1x, I'm going to rewrite it as minus 3x plus 4x. And then, of course, you have the minus 12 at the very end. So you put the minus 12 right there at the very end. And then you factor by grouping by separating them. X squared minus 3x plus 4x minus 12. And then you factor something out of the first group, which would be an x, and you would have an x minus 3 left over. And in the second group, you could pull out a what? 4. And you would also have an x minus 3 left over. And then you do some exaggerated parentheses. And then you pull out that common binomial of x minus 3. And what would be left over on the inside? The x and the 4. So your final factored form is x minus 3 times x plus 4. So the question is, why the heck would you go through all those steps when you could just think, what times would I see that if you combine together to be? Right? I just wanted to show you that it is possible, that it's there, right? This whole process is there everywhere, right? Step 1 is to multiply a times c. Step 2 is to make a list. Think of the multiples of that answer, right? So like on this one, a times c was negative 18. A times c was negative 18. We thought of the multiples of negative 18 that combined together to give us the b value. We rewrote it. Instead of 3 terms, you rewrite this as the 2 numbers from step 2, so you end up with 4 terms. Then you use factoring by grouping to be able to factor. Is there any other easier way of doing this? No. Will it become easier? Absolutely. The more you practice, the easier it gets, right? But this is not easy if you're asleep right now, Benji. But it will get easier if you're awake and paying attention, Benji. Benjamin. There you go. All right. Should I erase that? No, it's okay. It's going to be on there permanently forever on YouTube. Okay, wake up. Here we go. So you guys could do 2 and 3. That's going to be your homework, all right? The answers will be posted on Edmodo later, and they're also posted on the wall right there if you wanted to work on them right now and check your answers as you go. But before I let you loose, let's flip this paper over. Now let's get to the real fun stuff. See, we didn't do this part last week. Why not? Well, because on an equation, you want to be able to factor so you could get something times something equals 0. That way you could split the somethings and set them each equal to 0. That's called using zero product property. Are you with me? Okay. So we need to factor this. Now, we didn't do it last week. Why? Because we had the number 2 right here. The a value is not 1. But now we know how to factor these guys. It's that long process. So let me guide you through one of them. Which one would you like to see? 1, 2, 3, 4, 5. Which one?
4.
4? Okay, let's go to 4. Wow, this one's going to be ugly. Nice choice. What's step 1?
Multiply 8 times C.
8 times C. So what is 6 times 20? That's 120. By the way, your first step should always be trying to pull out a GCF, but right here there's nothing in common, so we actually have to jump right into it, 8 times C. So that's 120. So step 2, let's make a list of the multiples of 120. So I want to go 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20. Man, this is ridiculously long. 7, it's not going to work. 8 times something, give us 120?
No.
No. Yes?
Yeah,
60.
15.
Oh, wait.
15, right?
Yeah, 15.
15. And of course, with the calculator, you could just go 120 divided by 8, it'll give you 15. Will 9 work? No. Will 10? Yeah, 10 times 12. 11? No. That's it. Those are all the possible ways. Yeah, so I guess this is one of the most challenging ones because the list is so long. Now let's combine these numbers and see which pair of numbers combines together to give us the middle value, which is negative 23, the B value. And yeah, 8 plus 15, that's 23, but we want it to be a negative 23. So yeah, let's change that to a negative 8, change that to a negative 15. That's the correct number from step 2, the correct pair of numbers that we want in step 2. Now, if you read step 3, it says go back and rewrite your trinomial into a 4-term polynomial. The B value is going to change from a negative 23x to a negative 8x minus 15. So we're going to rewrite the B value as these two numbers. So let me rewrite the whole thing. We have a 6x squared. We have a not minus 23, I'm sorry. A minus 8. Let me rewrite it in blue here. Minus 8x, and then minus 15x. That's instead of the minus 23 that we had as a B value. And our C value is plus 20. So all we've done is change 3 terms to 4 terms. And why do we do that? So we can now factor by grouping. So let's go to this. Let's factor by grouping. What's the first thing to do?
Separate the
2
2 groups.
groups. 6x squared minus 8x, separate, minus 15x plus 20. There's my 2 groups. Next step would be to factor something out of each group. What could I pull out of that first group?
2x.
A 2 and an x. What would be left over on the inside?
3x.
3x minus 4. Okay, and how about that second group? What could I pull out?
5.
A 5. Now, if I pull out, okay, yeah. So this, I mean, yeah, we know that we need to pull out a 5, but do you see that this 3x is positive and this one's negative? This one's negative and that one's positive. So we would like the positive term here and the negative term there. In other words, we want different signs. So if we pull out a negative 1, it'll actually change this to a positive and change this to a negative. So let's pull out a negative 5. That way when you think negative 5 times what will get you a negative 15x? Oh, that'll just be 3x. And when you think negative 5 times what gets you a positive 20? Oh, that'll be a negative 4. A negative times a negative is a positive. And now we could see that we have that common binomial of 3x minus 4 in the first group and the second group. Got it? Okay, so now let's pull out that common binomial by writing some exaggerated parentheses right here. That common binomial will be 3x minus 4. What's left over on the inside? 2x minus 5. All we need to do now is rewrite it with the correct size parentheses. We have the 3x minus 4 times 2x minus 5. But they didn't ask us to factor. They asked us to solve. The only reason why we're factoring is to rewrite the original quadratic trinomial as a binomial times a binomial. Why is that? Because it's equal to 0. So I still need to set this equal to 0 to solve it. And we're going to apply the 0 product property to solve it. So 3x minus 4, that could be 0. And the 2x minus 5, that could be 0. So solving both of these, plus 4, you're going to end up with 3x equals 4. And you divide by 3. Final answer is x equals 4/3. That's one answer. The other one, add 5. You're going to end up with 2x equals 5. Divide by 2. Final answer, x equals 5 halves. Both of those are our answers to this original equation, quadratic equation on number 4. I said, dang, that's a lot, right? Fun stuff. I mean, seriously, if I were you, weekend comes around, go to a party, turn on the lights, turn off the music, tell everybody to gather around, show them how to factor quadratic trinomials and apply the zero product property. When the a value is not 1, that is instant popularity, guaranteed. I mean, it worked for me when I was in high school. I don't know about you guys. Okay. So, I hope that we could now complete the rest, right? How would you start number 1? That's right. Everybody write down. Number 1, a times c. What's the answer going to be? -6. Let's just go through the motions, even though you think you might know it. Step 2 is to think of the multiples of that answer. -1 times 6, -2 times 3, and that's about it. And then step 3 is rewriting the whole thing, but instead of your b value, Fernie, you're going to rewrite that 5x as the two numbers that you find from step 2. So which pair of numbers combines together to give us the b value of 5? -1 and 6, right? -1 and 6. If we combine those two together, -1 plus 6 really does give me 5. I don't need to change any signs. This is what I want. This is my winner right here. So let's rewrite the whole thing. It's going to be 2x squared, but instead of 5x, what do I write? -1x plus 6x. Where did I get these values from? From right here. Let's put -1 with an x and 6 with an x. 5x is the same thing as -1x plus 6x. And we still have the -3 at the very end. Going back to black, -3 at the very end. It's still an equation. Normally I don't really write this equals 0 till I already have it factored, right? So you don't have to worry about this right now. Let's just continue factoring by grouping. So, man, I wasn't going to do it, but I might as well just keep going, right? What's step 1 on factoring by grouping? Separate them, 2 groups. So you have 2x squared minus 1x. Separate plus 6x minus 3. The next step in factoring by grouping is to factor whatever you can out of the first group, which is obviously a what? What could you pull out of that first group? An x. 1x. You could put 1x or you could just put x. Same difference. So what would be left on the inside if I pull out an x? Come on, people. What's x times what gets us back to here? There you go. 2x minus 1. How about the second one? What could I pull out?
2x minus 1.
Well, what could I pull out, though? A 3. Okay, a 3. If you do pull out a 3, you will have 3 times what gets you 6x? 3 times 2x gets you 6x. 3 times what gets you a -3? 3 times -1 gets you a -3. So as you can see, the binomial is exactly alike, identical, common binomial, 2x minus 1, 2x minus 1. You are now to the step where you do exaggerated parentheses, and you pull out that common binomial of 2x minus 1 out here. And what would be left over? An x and a positive 3. You should put that plus in front of that 3, stating that it's positive. So this is what we call factoring. Now we could rewrite it. We should rewrite it with the same size parentheses. And now we should remember that this was an equation equal to 0. So we're going to bring that down, set it equal to 0. And now that we have something times something equals 0, the first something could be 0 or the second something could be 0. So let's do that. We have 2x minus 1. That could be 0. The x plus 3, that could be 0. Let's do some math here. Solve that first one. Plus 1 on both sides. You end up with 2x equals 1. Divide by 2, divide by 2. X equals 1/2. That's one solution right there. Subtract 3, subtract 3. There's your other solution. X equals -3. Ladies and gentlemen, let me link this back to graphing and the stuff that we did before. If I were to take the quadratic equation, y equals 2x squared plus 5x minus 3, that would open up. You'd have to modify the pattern of 1, 1, 2, 4, 3, 9. But it would be slightly narrower because it's vertically stretched by 2. And that parabola that's slightly narrower than that opens up would cross the x-axis. It would have the x-intercept of 1/2 and -3. So if I were looking at an xy plane, here's 1, it would actually cross right here at 1/2. And here's 1, 2, 3, it would also cross right here at -3. Parabola would be opening up like that. If you wanted to link it to that, you don't have to. I just want to link everything that we've learned so far. So anyways, I need you guys to complete this. Do question 5, do question 2 and 3, and go to the front side and complete anything that's not completed yet. That is your homework, to complete the notes and to complete that class opener. The answers are posted on the wall in the back, and they'll be posted on Edmodo.